Okay, I'm going to go over expectations of graphs with you that you will be turning in for this class. The last assignment that I graded actually specifically told you to draw the graph and not use a graphing program. I do not have a document camera, or I would have done this on paper myself. This is the best way for me to show you and model how to do the graph. So again, I am telling you, if it tells you not to use a program and to draw it yourself, you need to do it on paper. The Virtual Academy has graph paper if you need any, so you can go pick some up to have on hand if you ever need it, and then you will scan the graph and submit it, okay? Again, I would have done it on paper, but I do not have a document camera, so I can't show you and model it very well without, using my iPad. So first you will be given some data, or you'll have to collect some data. I've put a data table on this graph paper, and it says, using the data below, create a graph the way we discussed in class. I actually used this with another class. So the student controlled the pressure in this particular lab. All right, so the first thing you've got to do is draw the axes. So we need a y-axis. And since these are all positive numbers, okay, these are all positive numbers in the data table, we're going to just need quadrant 1. Okay, so we don't have to draw all 4 quadrants. So I'm kind of going to make more of a quadrant 1. All right, this is the y-axis. This is the x-axis. Okay, the x-axis always has what we call the independent variable, and the y-axis is the dependent variable. The independent variable, the way to identify which one's the independent variable is the one that the person performing the lab is actually controlling. Okay, in the directions it says the student controlled the pressure in this particular lab. Now, it may not just tell you that. It may, it may be a problem where it's giving you a situation and you have to use context clues to figure out which variable is being controlled. So we will label the x-axis with pressure. And behind pressure, in parentheses, is the unit. So that goes in parentheses behind pressure. Okay, that means volume is the dependent variable. So we label the y-axis with volume in milliliters. Sorry, my handwriting's horrible on the iPad. Now we need to figure out a scale. And to do a scale, we're going to look at the lowest number and the highest number. So for the y-axis, our lowest number is 1.6. Our highest number is 9. So up to 10 would be ideal. Okay, I'm going to make, let's see. I'm going to make every other, let me see. I'm trying to move. Oh, there we go. Make it more straight on that line. And this one. Okay. All right, so volume's going to go up to, I'll just do it up to 10. I'm going to make every other line tick mark. 5, 6, 7, 8, 9, 10. Okay. Oop, I skipped a line there. You need to make sure that your scale is, each tick mark needs to be the same distance from the one before, including the first one from the origin. Okay, and these are all by ones. Now they could be by twos, they could be by fives. It depends on your data. Ooh. I can't talk and write at the same time. I apologize. Okay, and then pressure, the lowest is 1 and the highest is 4.7. So I'm going to do by ones, or we could even space those out a little bit more if we wanted to. We could do it by fours, 3, 4, 5. Okay, just as long as that axis has the spacing identical and the quantities between each space identical. So mine are going up by ones, they're spaced out by 4 squares on the x-axis, and then they go up by ones and they're spaced out by 2 squares. Okay, now we can start, whoops, I'm trying to erase. We can start putting our data points in. So we're using the numbers in the table, 4.7 and 1.6. That's going to be our first point. So we go, since pressure is our X and volume is our Y, that's where we get our points. So 4.7 would be around here, maybe. And then 1.6 would be up to about here. Okay, they don't have to be perfect, just around, just do the best you can. Okay, I think I did it a little too high, actually. 4.7 and 1.6. Okay, and then 3.9, 2.0. And then 3.4, 2.4. And then 2.6 and 3.2. And then 2.5, 3.3. What was it? 2.6 and 3.2. .2 and 3.8. 2.0 and 4.4. Okay, so you're kind of getting the gist of it. And you would keep going. And then you could do a line of best fit if you wanted to. And that's taking a line and going, using the dots to create a line. Now, it doesn't have to touch every dot. If you do a line of best fit, it is using the dots to guide your line and making the best line with the data that you have. Okay, so that is what is expected of your graph. You need to have labels on your axes. You need to have units behind your labels. And you need to have your scales drawn correctly, okay, based on the data that you are graphing. Okay, if you have any questions, you can always email me.